So today what we're going to be looking at are the reactions of acids and bases. Now this word bases might seem new to you because the previous two videos I've used the word alkali. Bases and alkali are the same type of chemical, and the only difference is that an alkali is soluble and it must be soluble, whereas a base can be insoluble. A base can be insoluble. So any base that dissolves is called an alkali. So some bases are alkalis, but not all bases. And what we're going to do is we're going to look at the reaction of acids with three types of bases. And we're going to learn some general equations. So we're going to look at how an acid reacts with these three different things. We have got it reacting with a metal oxide, with a metal hydroxide, and with a metal carbonate. So those are the three types of reaction we'll do. Now notice the acid, we don't have a particular name for the acid, and with these ones we just call them metal oxide, metal hydroxide, metal carbonate. These are what we're going to call general chemical equations. So once you know the general equation, you can put in any acid, you can put in the name of any metal with oxide, hydroxide or carbonate, and you'll be able to say what the products are. Now, in every single one of these reactions, we actually get the same two products, but in this reaction at the bottom, we get a third product. So these two, the products are identical. In each one, we get water, and we get a salt. Now, by salt, that doesn't just mean salt isn't just the thing that you might put on your chips or the thing in the sea. Salt is really the name we give for any ionic compound, really, is a salt. So something that's made out of ions we call a salt. And in this one we get water plus salts. And in this one we get water plus a salt. So far pretty straightforward, but because it was a carbonate, we also get carbon dioxide. So we have acid with a metal oxide, gives us water and a salt. Acid plus a metal hydroxide gives us water and a salt. Acid plus a metal carbonate gives us water plus salt plus carbon dioxide. Now, why water is produced is something that we can actually easily understand. And it's to do with the ions that make something an acid and that make something a base or an alkali. The ion that makes something an acid is the H plus ion. The ion that makes something an alkali is the OH minus, or the hydroxide ion. Whenever we have an acid-base reaction, they come together again, and we end up with this. End up with this, which is H2O water. And you'll notice I've color-coded these things, and I've done that on purpose because that's the color that universal indicator would be. Red for an acid, blue or purple for an alkali, and then green for something neutral like water. And believe it or not, The fact that we get water, a neutral substance, in every single one of these reactions is what gives us the overall name for these reactions. These are called neutralizations. So all of these are neutralization reactions. And we always get water and salt. Water from the hydrogen ion and the hydroxide ion recombining. The salt comes from the metal part and part of the acid, and we'll learn about that later on. And we need to know that just for the carbonate, so just with the carbonate, we end up with carbon dioxide. What we're going to do now is we're going to look at some specific examples, and in particular, what happens whenever we react how do we name the salt, that is produced. So when it comes to naming salts, the names of salts have two parts. Part 1 comes from the base, and part 2 comes from the acid. And what I mean by having two parts, for example, sodium chloride. Part 1, the sodium, all comes from the base. Part 2, chloride, will come from the acid. So we'll focus on part 1 first. And we'll look at sodium oxide. And potassium hydroxide. And calcium carbonate. Well, when it comes to how do we know from the base what ends up in the name, it's just this metal part. So if it's a sodium, the metal oxide is sodium, then the salt is going to start with sodium. If it's potassium hydroxide, the salt is going to start with potassium. And if the if the base was a calcium metal salt or base, the salt is going to be calcium. So we just take the metal. Now the acids, they're a bit different. There are 3 acids that you need to know. So hydrochloric, nitric, and sulfuric acid. And each one of these gives a different thing to the name of the salt. So the first one, hydrochloric. Well, we see that it's got chloric in it, and it produces chlorides. So, just as an example, if sodium oxide reacted with hydrochloric acid, we would produce sodium chloride, like this. Now nitric acid has nitric, and it produces nitrates. So nitric acid produces a nitrate salt. So if potassium hydroxide reacted with nitric acid, we would produce potassium nitrate. And finally, we have sulfuric acid. Now sulfuric acid has got that sulfur in it, and this gives us sulfates. So sulfuric acid, sulfate. So if calcium carbonate reacted with sulfuric acid, the salt would be calcium sulfate. So let's just do an example. If we had iron oxide reacting with nitric acid, the salt would take the iron part from the base, and it would take from nitric acid, we know that nitric becomes nitrate. So the salt would be iron nitrate. And we need to be able to combine those two things together. So we need to be able to use the general equations and naming salts to give us full equations. So we'll do some practice of that. So full equations. So first one, we will do tin oxide plus hydrochloric acid. Well, it's a metal oxide plus an acid, so the two products are going to be water and a salt. Now we know how to name salts. We know we take the metal part from that, and then we look for the acid for the part that we're going to use, and for this one, it's the chloric. So our salt is going to be tin chloride. Our second one, let's try sodium hydroxide plus nitric acid. Well, it's a hydroxide, so we know we're going to get water plus a salt. Now the salt, we take the metal from here, and it is nitric acid, so we're going to be using that, and we end up with sodium nitrate. Third example, let's do copper carbonate plus sulfuric acid. Now with this one, it's a carbonate, so it's slightly different. We know we get water because every neutralisation produces water. We get carbon dioxide because it's a carbonate, and then we also get a salt. And with the salt, just like before, we take the name of the metal from here, then we look and we've got sulfuric acid, so we use this part, copper, the metal, then we have space, and sulfuric acid gives us sulfates. So that's the expectation, that you would be able to take any metal oxide, metal hydroxide, metal carbonate, and any of these three acids, hydrochloric, nitric, or sulfuric, and use the name of this, the name of this, and the type to know what the products are. metal oxides, metal hydroxides, water and a salt. And the salt comes from the names of the acid and the metal in your base. Copper carbonate, or any metal carbonate. You get water and a salt, but you also get carbon dioxide. Now the question becomes, how do you know? So how do you know that you've produced carbon dioxide? Well, one sign would be that if we're producing a gas here, but not in either of these ones, we would get bubbles. So that's a good clue. However, that's not a very chemical way of showing it, because other gases could have been produced that would give bubbles as well. So there is a test that you can do to check if you are producing carbon dioxide. And the setup looks a bit like this. So in your test tube here, you have your acid plus your metal carbonate. And you attach it, so you need a wee sidearm, and you attach it, get some tubing, that can be quite long, doesn't have to be that, and it goes into a container like this. And in here, we have lime water. So lime water is water with a calcium compound dissolved in it. And it is colourless to start off with. Now what happens is that if your metal's reacting with the carbon dioxide, you'll get these bubbles being produced, and they will go up, they'll go through here, and then they'll go down into here, and they'll start to bubble out through there and be able to escape. So this tube needs to go into the liquid so that your gas can bubble through it. It needs to go into the lime water, and then you need a second tube just so that any gas can escape. Otherwise you get a build-up of pressure. If you have carbon dioxide, this will turn cloudy, sometimes called turning milky. It just means it gets white. You start to see sort of a solid powder, white powder start to form. And that is our test for carbon dioxide. And you need to know that test, and you might need to be able to draw that diagram. We'll just review. Today we looked at the reactions of acids and bases, which we call neutralization reactions. We need to know that acids plus metal oxides produce water and a salt. Acids plus metal hydroxides gives us water and a salt. Acid plus a metal carbonate gives us water, salt and carbon dioxide. Water is always formed in a neutralization reaction because the hydrogen ion from the acid and the hydroxide ion from the base or alkali combine to give us a water molecule. And it's neutralization because if we end up with pure water and the reaction's gone perfect, our pH should be 7. We also looked at how to name the salts, and we looked at the test for carbon dioxide. So thank you for your attention today.